Hello, everyone. The test has been put up there, or assignment, I guess is we should be calling it. Let's see, I went over to campus today. I had to get some stuff out of my office, and that building right next to the MBCC is it's like a skeleton, but you see all the wires and piping going everywhere. And I don't know where all those people are going to park, but anyway, let me shut this window off.
What were you saying?
Oh, he's just talking about his trip to the campus.
Those buildings that they're putting up next to MBCC, like when we left, there was just like basically frames. Now they look like all they need are like the exterior put in. You can see all the pipes and everything. But the first thing I thought is that where are all these people going to park? The Adams lot is already kind of full anyway. So anyway, and other than that, nothing new to report. School districts are doing what they're doing. All right, so I'll start the broadcast here.
Are your high schoolers going back to school or no?
We have not been told yet.
Oh wow, dude, that's crazy.
Well, they're not. I mean,
yeah.
The Orange County whatever board voted last night to basically recommend everybody decide for yourself.
Oh, so they can choose? Every school can choose on their own?
Every district.
Oh, wow. And so I have a feeling that they're all gonna, kind of like the reason why everybody's been closing. Nobody wants to be the first one to have a bad case or anything. So.
Santa Ana Unified announced that everything's online.
Really? Wow. That's a bummer for Santa Ana. There's a lot of people there who probably don't have reliable internet connections.
Then there's a lot of people, I mean, my wife works in Santa Ana College. There's a lot of people that, just like in LA,
the kids get the food and need the.
Yeah, they rely on the meals and stuff. And I mean, not that doesn't go on here. It also does here, I guess. But
it took them a long time to get the food. Like it took them quite a bit of time from what I read. Like it wasn't immediate transition. So.
All right. Well, let's see here. So today, by the way, so I put the due date as tomorrow at 5 o'clock. That'll give you 24 hours to work on the thing.
Cool.
All right. So we're going to do calculus.
Can you, before we get into the new stuff, man, I was looking over that test and I'm realizing I don't have a ton of notes that are non-theoretical that have actual numbers for like surface area problems. So I have very few examples to follow. I was wondering if you wouldn't mind doing like a surface area problem. Doesn't have to be from the test, but that just has some numbers, like not just trigonometric stuff, just straight numbers, like 4, and if you don't mind, like if you don't want, I understand. But
so let's see if this one works. Y equals the square root of x about the x-axis. Okay, so the area is the integral of 2 pi y ds. And now we have to decide if you want to do a dx or a dy integral. And so if we're going to do the dx integral, it's going to be from a to b, and that's going to be 2 pi y 1 plus y prime squared dx. Okay, so y prime is going to be 1 over 2. I don't know if this is working or not. Okay, I just made this up right now. 1 plus y prime squared, 1 plus 1 over 4x. So the area, the integral from 0 to 1, 2 pi y, which is the square root of x, times 1 plus 1 over 4x dx.
Could you just scroll up a little bit? I apologize. I'm trying to write as fast as possible. There we go. Sorry. Plus 5 prime 2. Okay. Very similar formula to the curve.
Yeah, it's just the area formula. Okay, so then this is 2 pi radical x, and then I'll common denominator this. Okay. And then this would be 0 to 1, 2 pi square root of x, square root of 4x plus 1, square root of the bottom is 2 radical x. And so the 2's and the radical x's go away. And now it's going to be pi integral from 0 to 1 of the square root of 4x plus 1 dx. So if you u sub this, you go u is 4x plus 1. Du is going to be 4 dx. When x equals 0, u equals 1. When x equals 1, u equals 5. So u substitution. Pi integral from 1 to 5 pi over 4, and then it's going to be u to the 1/2. So it's going to be pi over 4, u to the 3/2 over 3/2, evaluated at 1 and 5. So that's going to be pi over 6 times 5 radical 5 minus 1.
Okay. Yeah, thank you. 1 second. Sorry, I'm still just writing as fast as possible. Thank you for doing this. Okay, pi over 6. And that's the answer. It looks like that. Pi over 6 times 5 to the square root of 5 minus 1.
Mm-hmm.
Wow. Okay. Just they don't look like. I wouldn't know if you would do 5 to the square root of 5 pi over 6 minus pi over 6. Be what I would have written, but I guess not.
It doesn't make any difference. No.
Oh, okay.
Okay, now what you don't want to do, everybody listening, on the test or assignment, no decimals.
Okay.
Okay?
Yeah, I kind of feel like you've never liked decimals. Yeah.
No, because A, they're not the correct answer, and B, just numerically integrate stuff that, you know,
They're not
Try to-
exact.
trying to
Well, he-
somehow encourage you to try some stuff. Okay. So let's see here. We're going to start with in 10.4 areas from polar curves. Okay, so if we start, like, let's say we've got just some random r is equal to r of theta, and theta is going to run between alpha and beta. Okay, so a picture of this might look something like this, where it's doing something like that. Okay. Okay, now remember that we're not talking about stuff in x, y. Okay, so this is a perfectly good function. And if we were to go out and angle alpha, and then maybe, start over. Okay, so we got here, here, and then here's our polar curve like that, okay? And this is the X and the Y grid. This angle up here would be alpha. And then this angle, drawing up to here, would be beta. And what we want to do is get all of this area, okay? All right. Now back in Math 180, what we did is we had a curve y equals f of x, and we used rectangles to approximate the area underneath the curve, okay? So we probably not much use with rectangles here because all of these regions are, for the most part, if you start and stop at alpha and beta, you're basically going to get something, you know, that has like a sharp thing there. Okay, so rectangles probably not going to help very much. All right. What might help a little bit though is if we were to like dissect up this region. I hate, why does this eraser do this? Okay. Okay, so once again, here we go. Okay. And here is the alpha angle. Here is the beta angle. Okay, so if we were to like maybe cut this region into two pieces, okay, and then pick like an arbitrary angle in between
Trời ơi,
these,
xuống nước nhiều vậy?
Giờ mới ấy luôn hả?
like that,
Oh.
and maybe like that.
Giờ mới chịu ăn hả?
Okay, hold on. Hmm. Share the screen. Okay, so what the hell is it? You are sharing. Oh, okay. There. Okay. So if I picked a couple guys in there and then like drew like a portion of a circle that has radius that much, again, maybe draw a portion of a circle that has radius this much, then all of this stuff, which is like a slice of a pizza, is going to be approximating the area of that little piece, okay? So in order to do this, we're going to need to know what the area is of a sector of a circle. Now there's various ways that you can accomplish this. If the circle has radius, let's say R, okay, the entire area, and if this was an angle out here, down here, theta, if this went all the way around, okay, the area is going to be some portion of pi r squared. The portion that it is going to be is theta divided by 2 pi. Okay. And so what we get is this formula from our days in, I don't know what, pre-calculus, I guess, 1/2 r squared theta. Now again, theta must be in radians. Okay. All right. So here's what we're going to do. we will partition our interval alpha beta into this alpha less than theta 0 less than theta less than theta 1 less than dot 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 less than theta n, which is going to be beta. Okay. And then we will pick some theta I star in each of these subintervals, sort of like the xi star. Okay, some arbitrary guy. Okay, now back up here, let's say this picture right here. Okay, so we're going to take this area and add it to this area, and then so on and so forth. Okay, so the area that we want is almost equal to, would almost be equal to the sum I equaling 1 to n of 1/2. Okay, now the width of each one of these subintervals is going to be delta theta. Okay, delta theta is going to be beta minus alpha over n. Okay, the radius that we got is coming from this point right here, which is it's r of theta I star comma theta I star. The radius is that thing. So this is the guy that gets squared. R of theta I star squared, and then delta theta. Okay. And once again, at some point, we always have to just define it. Define the area to be this limit as n tends to infinity of the sum I equaling 1 to n of 1/2 r of theta I star squared delta theta. And we don't have any maneuvering here because this is a straight up Riemann sum for the integral from alpha to beta 1/2 r of theta squared d theta. And so that is our formula. Okay. All right.
You just hold for 1 second. You're still writing this.
I'll hold it here. I got to run to the kitchen and get something to drink. I thought my drink was full. Be back in a second.
Oh, this stuff's crazy.
It's a little bit intense. I was reading it last night and I was like a little bit lost, but looking at this equation while he's doing it makes more sense.
Oh yeah, man. I wish I was there with you. I like seeing stuff with like numbers, and I get that theoretical stuff's really important, but sometimes it's hard for me to like put together the theory when it's like, oh, okay, it's a lot easier when I see like, oh, there's 2, there's 3, you know, and I put those together and then I can see the math at work.
Well, technically this is a number. When you plug all the stuff in, just look at it as letters for now, just because in your mind, it's easier to store things as letters and then later on sub in the numbers. For example, the radius is usually 1, 2, 3, 4, you know, like simple little numbers. Or
Yeah.
it could be like, you know, unless it's like 1 over pi, 4 pi, right? Now the theta is usually always a degree, but a degree in radians.
All right, here we are. Kids left
Yeah,
their McDonald's
later
on the table,
Yeah.
and the dog was up on the table eating McDonald's. Okay, so let's try one of these guys. Okay, so for example, for this r equaling 1 plus sine theta. You remember this guy from yesterday? It was a cardioid. Okay, and it starts here, gets big, comes down, goes back up like that. Okay, and so it goes through an entire cycle up to 2 pi. Okay, so the area of this guy would be the integral from 0 to 2 pi. Then I have a 1/2, 1 plus the sine of theta squared d theta. Okay, now this is just an integral that we just square out and do. Okay, since there's no square rooting or none of this stuff, pretty much all of these guys should be doable. Okay, 1 plus 2 sine theta plus sine squared theta d theta, 1/2 the integral 0 to 2 pi. Okay, 1 plus 2 sine theta plus 1/2 minus 1/2 the cosine of 2 theta. Okay, and so 1/2 0 to 2 pi. I have a 3/2 plus a 2 sine of theta minus a 1/2 cosine of 2 theta. Okay, so that's going to be 1/2 times 3/2 of theta minus 2 cosine theta minus 1 over 4 the sine of 2 theta, evaluated at 0 and at 2 pi. Okay, I'll give you a second here. Okay, so if I plug this stuff in, it's going to be 1/2 of 6 pi over 2 minus 2 times 1 minus 1, because the cosine of 2 pi is the same as the cosine of 0, minus 1/4 times 0 minus 0, because the sine of those angles is 0. So what we get for our troubles is 6 pi over 4, which is 3 pi over 2. All right, so the area of all of those cardioids, whether they're pointing up or down or however they're doing it, their areas are 3 pi over 2. And there you go.
Hey, Bobby, that's minus 6 over 4, right?
Not
0
minus.
minus 6/4 over times 0 over 0. That squiggly line, that's a 6, right?
That's a 1.
Oh, thanks.
It's the 1 from this guy.
Oh, okay. That's why I was wondering. I was like, that. I was curious where you got the 6.
Yeah.
I have a question.
Okay.
So you like you input the 2 pi in the equation, but you didn't do the zeros.
They cancel out, and they stay 0.
Well, the
Oh.
cosine of, so right here, the cosine of 2 pi is 1. And then I would
Okay.
go minus the cosine of 0, which is 1. So it just goes away.
Oh, okay.
Okay, now this problem was fairly easy. All right. And for like the next one, I'm going to do much faster. Okay. Find the total area bounded by R equals the sine of 2 theta. Okay, so I wanted you guys to go kind of look at this stuff last night a little bit. But the sine of 2 theta is the flower that has the 4 petals off the axis. Okay, so if we can find, so if we can just find the area of one of the petals, then by symmetry, the area would be this 4a1. Okay, now as far as this first petal goes, we do a close-up on it. It comes out and then it comes back. Okay, so when does it get back to here? Theta is going to start at 0. Now, the R is going to get back to 0. Okay, so when theta goes from 0 to pi over 4, we get to right here. Okay, and so when we get to pi over 2, the sine of 2 times pi over 2 is going to be the sine of pi, which is also 0. Okay, so our area is going to be 4 integrals from 0 to pi over 2, 1/2 sine squared of 2 theta d theta. So that's going to be 2, 0 to pi over 2, 1/2 minus 1/2 the cosine of 4 theta d theta. Okay, and so this is going to equal theta minus 1 over 4 the sine of 4 theta evaluated at 0 and pi over 2. Now again, all of these are going away. Okay, so the answer is just pi over 2.
Yeah, because
So
it
this
just
is,
loops back, right? It just loops back around at 0.
yeah, it goes out like this to pi over, when it's pi over 4, like this, and then it's going to come back. Okay. Okay, now the problems that are a little harder be like this. Just kind of take one out of the exercises here. Okay. For example, I'd like to find the area inside of both R equals sine of 2 theta and R equals cosine of 2 theta. Okay. Okay, so we go to graph this thing. like this. And the sine guy, he has this leaf like there. And the cosine guy, he's going to have another leaf like that. Okay. There's also going to be up here another place of intersection where it's going to come across like that. Okay, so how many of these things are there going to be? Well, let's see.
8.
8 of them? I think so. There's going to be 2 in each quadrant, right?
Yeah.
Okay, now, here, let me do this in blue. See these little blue areas? These are the things that we're talking about. Okay. Okay. So let me draw one leaf of the cosine guy. Remember, cosine lives on the axis. Okay. And then this is the other leaf of the cosine guy. The sine guy comes out like this, comes back like that. Okay, and again, what we're trying to find is all of this stuff. Okay, now, we know that this is the line theta equals pi over 4. Okay, and it has to do with the sine guy. Okay, when theta is pi, the sine guy is starting here and he's moving this way. Okay, and when it gets to pi over 4, 2 pi over 4 is a pi over 2, sine of pi over 2 is 1. Okay, so I think it might be of use to us to figure out where these guys intersect. Okay, so let's draw it again. Now this time I'm only going to draw that little part of it. Okay, so this guy came down like this. This guy's coming over like this. And we need to figure out what this angle is. Okay. Okay, so just by symmetry, it looks to me like the theta is pi over 8. Okay, but just to be sure, let's look at this. Okay, let me finish this drawing over here. And then this one there. Then I have, oh no, not that. Then I've got this guy coming out like this. There's a guy coming out like this. This guy coming out like this. No. The guy coming out here, and then he comes back in. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and if you count the middle, 9 places of intersection. Okay, so how would we find such a thing? We would set the sine, r equals the sine of 2 theta, equal to the cosine of 2 theta. All right, so when do we know that the cosine and sine agree? If 2 theta is equal to pi over 4, that's certainly 1, right? And 2 theta could also be, whoops, I forgot to put the end of this guy there, plus any multiple of 2k pi, okay? Or 2 theta could be, say 1 pi over 2 pi, 5 pi over 4. Plus 2k pi. Okay, so this means this first batch, theta is going to be pi over 8. That's our guy that we looked at, plus k pi. Here, theta is going to be 5 pi over 8 plus k pi. So if we go through and list all the thetas that we're going to have, this guy is going to give us theta is pi over 8. And then if we add another pi, we'll get 9 pi over 8. If we add 2 pi, we get back to where we started. Okay. And then this one, we get 5 pi over 8. Okay. And then 13 pi over 8. All right. Now, this seems, before we, even solve this calculus problem here, this seems troubling because we can clearly see all of these points of intersection, yet we're only coming up with 4 of them. The ones that we appear to be coming up with is this one, this one, 5 pi over 1, 2, 3. Where's 5 pi over 8? It's 4 pi, it's this one, and whatever one's opposite of it. I believe it's this one. This is 13 pi over 8. 12 over 8 is 3 over 2. Yeah, so this is what we're getting. Okay, so these other guys are mysterious. Okay, now I think that this deserves some investigation because this can't be. Okay, so anybody want to venture a solution to this dilemma before I tell us all how it's coming to pass?
Please listen. Even public health experts.
Nope. Okay. Well, the way that we can get the others is by recognizing that the cosine of negative x is the same as the cosine of x. You got that?
Yeah.
Okay. Still waiting.
So we will have the same value, but with minus. Like for example, pi over 8 minus pi over 8 minus 9 pi over 8. Is that the other numbers?
Well, it looks like this one, this guy right here, I'll do it in blue. This guy right here, this guy looks like, as you said, negative pi over 8, right?
Yes.
It looks like it. Okay. So let's see here. If we were to say that if the sine, so if we were saying if the sine of 2 theta is going to be equal to the cosine of 2 theta, then wouldn't that imply that the sine of negative 2 theta would equal the cosine of negative 2 theta? Anything that works here should work over here, maybe. Okay. Well, anyways, when you follow this through, what we get is that the cosine of 2 theta is, because sine is odd, this is going to be negative sine of 2 theta. So now we have to go through a list where sine and cosine are opposite of each other. Okay, so that happens in quadrant 3. 2 theta could be 3 pi over 4, right, plus 2k pi. The other place where they have opposite signs is in the 4th quadrant. Down there, it would be 7 pi over 4.
Did anybody else get kicked out a few seconds ago?
I didn't.
I didn't.
I just got kicked out and I just logged in back again.
Yeah, it happens. I've had that happen before too. It just sucks. Just Zoom.
Okay. All right, so these are now our mysterious missing guys, okay? The theta is going to be 3 pi over 8 plus k pi. Here, the theta is going to be the 7 pi over 8 plus k pi. All right, now, next semester, for you guys that are moving into 280, you're going to be dealing with a lot of this kind of stuff. Kind of maybe towards the end of the class a little bit when you're, well, I mean, I don't know how your professor organize it. But when the polar stuff comes up, you always got to be wary of this weird phenomenon that because we've made all these identifications and stuff like that, sometimes you're seeing things but it's really hard to show them. Okay, so anyways, our thetas that we end up with is going to be 3 pi over 8. Somebody's going to have to mute 1 pi over 8. And then 7 pi over 8. And 8 plus 7 is 15 pi over 8. Okay. All right, well, now that we've solved that little dilemma, let's look at that area problem we had. Okay, so we're back to this now. And this is the pi over 8. All right. So this is the theta equaling pi over 8. And what this region is, if I scroll all the way back like this, okay, you see it right there? So it's that little wedge. Okay. So it's this wedge. Okay, now, which piece is from which? Okay, so maybe what I need to do is redraw it again, just so you can see it. Okay, so the sine guy does this. The cosine guy does that. Okay, so this is r equals cosine of 2 theta. And this is the r equals the sine of 2 theta. Okay, so this could be a bit deceiving, all right? This top piece, this is coming from r equaling the cosine of 2 theta. The bottom piece is coming from r equals the sine of 2 theta. Right? Okay, so how do we find the area of this little guy? Integral from 0 to pi over 8, top minus bottom. Is that the correct formula? There's a well-defined top, well-defined bottom.
Yeah.
Okay, well, remember, we're in polar coordinates, okay? And so we have, in order for this to be done, we have to have a well-defined like outer spot and inner thing, okay? Remember, our formula isn't top minus bottom. Our formula, okay, so this is wrong. This right here, okay? Now, I make it a point every semester to point that out. There are a few things that are wrong that I need to point out they're wrong, and they're as important for me pointing them out to be wrong as other things are pointing out to be correct, okay? Very easy mistake here, okay? You've been top minus bottom, okay? Now it's a little different. Okay, well, there isn't anything I can do to like outside minus inside. When we have like the area bounded between two polar curves, you know, like let's say we were doing one like the cardioid and intersecting with the circle of radius 1, we might, you know, this is a standard problem, find all this area. Okay, well, if you blow that up, okay, you've got a piece that's doing this, and then a piece that's circular in here like this, but it's the outer minus the inner. So if we found all of this area, right, and then subtracted off all of the blue area, we would get exactly what we want, which is all of this stuff up here, okay? So when we're in polar, you think outer minus inner. Okay, now there can be some confusion there as well. There's problems that say outside and inside. I'll do one of those in a minute, okay? All right, so what we're gonna do with this guy is we're gonna recognize that these two regions must be the same, right? Okay, now we needed some kind of a justification for that. So as long as they are the same, then what we can do at this pi over 8, let me draw the pi over 8 line. So this is theta equaling pi over 8. This is x and y. What we can do is figure out what the area is of this piece. Okay, so we'll call that area A2. Okay, then the total area is going to be 2 times the number of these regions that we have, which is 1, 2, 3, 4, 5, 6, 7, 8 of them. Okay.
We're not counting the middle.
Huh?
We're not doing the middle one, which is 0.
No, we're not. We're talking about regions now. We're not talking about
Okay.
intersections anymore. Okay, so the total area that we want is going to be, let me write it like this, is going to be, there's 8 of these flowers. Each one of these flowers can be busted up into 2A2. Okay, now, the reason that these things are look like they're the reflection of each other across that line, right? The sine guy, they both hit this spot when they get to pi over 8. Okay? And cosine ends the way sine begins, if you remember. Okay? So these regions must be symmetric. Okay, so we go to our formula now. Our area is going to be 8. Well, no, it's going to be 16. Our area is going to be 16 times the integral from 0 to pi over 8, and then it's 1/2 the r, which is the sine of 2 theta squared d theta. So now that's 8, 0 to pi over 8, and the sine squared of 2 theta is 1/2 minus 1/2 the cosine of 4 theta d theta. And so this is going to be 8 times theta over 2 minus 1 over 8 the sine of 4 theta, evaluated at 0 and pi over 8. Okay, so now this is going to be 8 times pi over 16, okay, minus 0 minus 1 over 8 times the sine of pi over 2 minus the sine of 0. And so clean this up a little bit, and this is going to be pi over 2 minus 1/8. And as long as I didn't make any mistakes, I didn't try to anyway, that's the correct answer. There's a little chance to catch up here. I got to shut this gate outside. It doesn't latch. It slam. All right, so areas inside of curves, outside of curves. Let's do one more of these guys like this, kind of from the book. So on the area, inside find the area of the region was inside of both curves. Okay, inside of there's this R equals inside the first 1 minus minus one, I think so, sine theta, and outside R equals 1. That's supposed to be outside. Okay. Okay, so we need to figure out what these things look like. So the 1 minus sine theta, let's see, it's when r is 3 pi over 2, it's going to be the when it's at the 2. Okay, so this is one of these guys that's going like this. It's going to go out like this. No,
And I lost.
lost it there. Okay, so it's going to be like that and like that. And then here's the circle of radius 1. Okay, so we want inside of the cardioid, yet outside of this circle. So what we are looking for is all of this area. Okay. All right, so looks like there's a well-defined outer and a well-defined inner. It looks to me like the guy that's out, it's the outer, not outside, but the outer is the r equals 1 minus sine theta. Okay. And the inner looks like r equals 1. Okay, so now the formula obviously is we figure out all of the total area here, all of this stuff, right? And then we're going to take away everything that's inside the circle, okay? And that's going to leave us with exactly what we want. Okay, and we probably should figure out where this and these guys are. Okay, so to do that, what we'll do is we'll set 1 minus sine theta equal to 1. So that means that sine of theta is equal to 0. So that's kind of unusual. What do you think that angle is?
0.
Okay, so when theta equals 0, let's draw this picture again. R equals 1 minus sine of theta, and R equals 1. Okay, so I'll draw the big picture here. So the reason this does this is because I'm all sideways. Okay, so there's that. Yes, lost it down there. Okay, circle of radius 1. So something like that. No. So the circle of radius 1, doing something like that. And then this cardioid guy, it starts here. And as theta increases, it goes like this, then this, then out all the way around to 2, and then back in. Okay. So it looks like I was, fuck. Oh, wait,
Left corner.
You could do the un.
there we go. Okay, so it looks like I had it right. I just had drawn a funky picture. Okay. By doing it more carefully, we see that the theta is 0, and it also is at pi. Okay. All right, now the bounds of these guys are going to be a little tricky. So the area that we want is this area. Okay. So if we did the cardioid, if we did the r equaling 1 minus sine theta guy, the area there, let's call that area 1, would be the integral, okay? Now the cardioid, it starts here at 0, pi over 2, so it would be pi to 2 pi, 1/2, 1 minus sine theta squared d theta. Okay, now that is going to give us all of the area. It's going to give us all, I want that. It's going to give us all of this area. Okay. And then area 2 is I'm going to subtract off the circle. Okay. Oops. So if I just subtract off this area right here, this half of the circle of radius 1, isn't that going to be what I'm trying to do? What's the area of the whole circle of radius 1? Pi, right? So what's the area of half of it? Pi over 2, right? So the area in question then is this A1 area. Then when it's all said and done, I got to subtract off pi over 2. Okay, so, but you guys want me to do the integral? 1/2, go to pi to 2 pi, and then it's 1 minus 2 sine theta plus sine squared theta, which is 1/2 minus 1/2 the cosine of 2 theta. Okay, so this is going to be 1/2 times 3/2 of theta plus 2 cosine of theta minus 1 over 4 the sine of 4 theta, 2 theta. All evaluated at pi and 2 pi. Okay, so this is going to be 3 over 4, 2 pi minus pi plus 2. Cosine of 2 pi is 1. Cosine of pi is -1. Okay, and then minus 1/4. Well, these are going to be zeros. Okay, and then I got to subtract off pi over 2. So this is going to be 3 pi over 4 plus 4, right, minus pi over 2. So I think the answer is pi over 4 plus 4. And I always like to do a little reality check here. What did we find that the area of the whole cardioid was? You guys remember? Wasn't it 3 pi over 2?
Pi over 2.
Okay. Can this number be right?
No,
Doesn't it look like it's too big?
it's too big.
Looks too big to me. Where the hell's my phone? Can't find find my calculator. Sitting up. So if we look at 3 pi over 2, 3 times pi over 2, 4.7 something. 4 plus pi divided by 4 is giving me 4.7 whatever. So there's something amiss here. Okay. So let's scroll back and see what we did wrong, if we can find it. And then I put my pencil down somewhere and it's, geez, losing my shit here. I put stood up to look for a phone. Put the Apple pencil down. Shit. Having a little crisis, guys. Can't find the pencil. All under here. Nope. Okay. Didn't just get up and walk away, did it? All right, guys. Give me a moment here while I look for this thing. There. Okay. So let's go back. Okay, so here was 1 minus the sine and the r equals 1. Okay, that looks pretty good, doesn't it? Circle of radius 1. That thing's going out to 2. Okay. Now, if we integrate the cardioid from pi to 2 pi, here's what it's going to look like. Okay, it's going to be starting here, and it's going to be mapping out all of this stuff, where that's -2 down there. Okay, so that integral from pi to 2 pi is going to give us that number. All right. So let's do it again real quick. For this guy right here, it's going to be the integral from pi to 2 pi, 1/2 the r squared, the sine of theta squared d theta. Okay. All right, so now I'll put this guy outside. Start doing it down here. 1/2 pi to 2 pi, 1 minus 2 sine of theta plus sine squared theta d theta. All right, and so that's going to be 1/2 pi to 2 pi, and then it's going to be 1 minus 2 sine theta plus 1/2 minus 1/2 the cosine of 2 theta d theta. Okay, this time I'm going to do it a little slower now because I don't think we were right the first time around. Integral pi to 2 pi. Then it's going to be a 3/2 minus a 2 sine theta, and then minus 1/2 the cosine of 2 theta d theta. So this is going to be 1/2 times 3/2 of theta, and then plus 2 cosine of theta, then minus 1/4 sine of 2 theta. And all of this is going to be evaluated at pi and at 2 pi. So this is going to be 3/4 2 pi minus pi plus the cosine of 2 pi minus the cosine of pi, and I think I just found the mistake. The 1/2 that I never canceled that with that. Okay, and then minus 1/4, 0 minus 0. So the area of that part of the cardioid is going to be 3 pi over 4 plus 1 minus 1. So that part of the cardioid is 2 plus 3 pi over 4. And just to get a kind of a handle on how big that is, 2 plus 3 times 3.14 over 4, 4.355, whereas 1.5 times 1.34 is 4.7. Okay, so it is less. Okay, so now for the area that we want, our area is we take the 2 plus the 3 pi over 4, and then we just subtract off the pi over 2. Okay, so this is going to be 2 plus 3 pi over 4 minus 2 pi over 4 is 1 pi over 4, as opposed to pi over 4 plus 4. That was the too big number. Okay, so I'm pretty confident with that guy. All right, so that's how we do areas.
And that's just the area of the inner cardioid, right? I mean the outer, the outer inner.
This is the area of this right here.
Yeah, that.
And then I'm just subtracting off half of a circle.
Okay.
Okay. All right. All right, so next thing maybe we want to talk about is arc length, okay? And I did put some problem, one problem, maybe two, on your exam that's dealing with arc length and parametric equations and stuff, okay? Okay, so again, we have this curve, you know, in the XY grid, R equals, you know, some function of theta, you know, and who knows what it looks like, might do something like that, okay? And we want to know how far it is from here to here, okay? Okay, well, let's call this R, just for now, f of theta, okay? Now, if we had this curve, like, okay, so the points on this curve, which are in here, are x, y. And if you recall from yesterday, x is equal to r cosine of theta, and y is equal to r sine of theta. Now, since r is a function of theta, our x has been parameterized with this theta, f of theta cosine theta, and the y is also a function of theta. And we already worked out how to find arc length with parametric equations. So for parametric equations, the length of the curve is going to be the integral from t goes from a to t equals b. And then it's going to be this dx dt squared plus dy dt squared dt. Okay. All right, well, because our x's and our y's are now parameterized, we can just use this formula, okay? So x is r cosine theta, and y is r sine theta. So now I'm going to go back to put the r in. Okay, now, what is x dot? It's going to be dx d theta. Okay, so it's the derivative of this piece. Remember that that's a function, dr d theta, times cosine theta, and then plus the derivative of this guy, sine theta, negative sine theta, times the r. And the y dot, which is dy d theta, is going to be dr d theta sine theta, and then plus r cosine theta. Okay? So what we're going to do is we're going to add up x dot squared plus y dot squared. Okay, so it's going to be r dot cosine theta minus r sine theta quantity squared plus this r dot sine theta plus r cosine theta quantity squared. Okay, so let's start multiplying this out. R dot squared cosine squared theta minus 2r dot sine theta cosine theta plus r squared sine squared theta. plus, okay, now this is going to be r dot squared sine squared of theta plus 2r dot sine theta cosine theta. See what's happening here? Plus r squared cosine squared theta. Okay, now when these things get added up, what we end up with is r dot squared times cosine squared theta plus sine squared theta plus r squared sine squared theta plus cosine squared theta. So what we end up with is that x dot squared plus y dot squared is equal to
Anyone else get him cutting out?
Yeah, I got cut out again. I got thrown out.
No, I mean, see, is anyone else getting that he's not speaking?
Oh, wow.
Yeah, I don't hear him either.
Yeah, okay, cool. I just want to make sure we're all there together. Did anyone get 10? Nobody seems to know how to do it. Crazy hard.
On the exam right now?
Yeah, very hard. Yeah, I haven't been working on it. I've been trying to follow along with this lecture, which is very difficult. But it's, yeah. 10 is like, some people are thinking that it's literally an impossible problem because people on Khan Academy can't even do it.
It might be that one that he put on there that will test us to see what's going on, if you know how to do it.
Yeah, I think all of those are there, man. I think every single question I put on there to test us, see if we know how to do it. If people on Khan Academy can't do number 10, then I think that's a little bit outside of our league. But yeah, we'll see. I mean, I don't know. Maybe he's listening to us talk and I really don't mind. But I'm wondering if this is the end of class for today. It's so late to try to continue from here.
Is this the old problem, right? I'm looking at right now on the screen that's frozen.
The screen is frozen, and this problem has something to do with x equals r cosine theta, some arc length or some crazy problem.
Yeah, but like, did I like? I know I just got kicked out a few seconds ago. I don't know. I left out at r.
Yeah, I got r
sine
squared. R squared minus is where he froze.
Okay, so this is the old problem from another.
I mean, he's probably going to come back and it's already done. Like this has happened several times in the past.
I mean, he probably got kicked out like I did, or
yeah, good. I mean, I've had that happen. Zoom is, not perfect by any means, and way too many people use it now. It was not probably when they created this, they probably didn't expect nearly as many people to ever use this. I actually don't know how it became the primo facto version. I don't know how like Google Hangouts and all those other ones got skipped, but I'm actually like super confused, to be honest. like how Zoom became the one that everybody uses now. Like,
I thought it was going to be Skype since Skype was like old.
Yeah,
and
Skype.
like,
Yeah, I thought they were going to use the old one too. Yeah, Skype sucks, but I thought they would use the old one. The thing that I don't get about Zoom is like Google Hangouts. I mean, maybe they have a charged level, but I've used it tons of times and there's no pay wall that I've seen. So whereas Zoom, I mean, if I create just a private Zoom chat, there's a paywall if you use over 40 minutes, unless they decide to forget it. So it's like the weirdest choice.
Yeah, because Skype is free unless the other person doesn't have it.
Yeah, I mean, they probably could have got Skype. They probably could have done Google Hangouts. I mean, I'm sure there's dozens of other options I'm not even thinking of. But I mean, Zoom's fine. I don't hate it. I just.
How long ago did I get kicked out?
Quite a bit ago. You had so x dot squared plus y dot squared equals r squared minus, and then you got kicked out. So I don't know where that is in your notes, but it was probably
Okay, hold on. Let me.
5 minutes ago.
It's been 5 minutes.
I would assume.
I got
Yeah.
tired. Yeah,
Talked for a
that's
while,
about.
so.
I don't know what happened here. Okay, so share the screen. Just go to, there we go, OneNote. All right, so this is where we were. Okay, and I'll start that. Did we get here?
A second.
Down a little bit more.
Down,
Down, down.
down, down, not up. Yep, down. There, down a little bit more.
That's
Down,
right.
down, 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 down. So there you go. There, stop, stop, stop. So x dot squared plus y dot squared equals r squared minus r dot squared.
Plus.
Or plus, sorry. Thank you for catching plus r dot squared. Now we do the length formula.
And then I just fed it into the length formula. Okay, so that's our formula.
Wow, wow, wow. 1 second, 1 second. That's very far advanced.
Oh, can you go up just a little bit more? There.
So when we need to finish exam 2? Oh, by 5 p.m. tomorrow, James.
Okay, I started working on the cardioid now.
Okay.
All right, so goes around 0 to 2 pi, right? And this is the r squared. That is the r dot being squared. And where it eventually takes us is to this integral right here. Okay, so let's see here. Cosine squared of x is equal to 1/2 plus 1/2 the cosine of 2x. So that means 2 cosine squared x equals 1 plus the cosine of 2x. So 2 cosine squareds of x over 2 is going to be 1 plus the cosine of x, right? So I'm going to factor this square root of 2 out of here and go 0 to 2 pi. And it's the square root of this 1 plus the cosine of theta d theta that we just figured out was the same as 0 to 2 pi square root of 2 cosine squareds of x over 2. I mean, theta over 2 d theta. And so the radical 2's are going to pop out. Square root of cosine squared. This is me, the cosine theta over 2 d theta. So I'll integrate that to give me 4 times the sine of theta over 2, evaluated at 0 and 2 pi. So that's 4 times the sine of pi minus the sine of 0. So that's 0 minus 0. So the answer is 0.
Oh.
Any questions on that one?
And this is for the area between the 2 points.
No, it's the length of the curve. Remember, we're finding
Yeah.
length.
Oh, okay.
See, back up here, it's length.
For the cardio on the cardio.
Yeah. Are we good? Move on.
Sure.
Really?
I mean, we could do another one if you want. A lot slower, and and then
Oh,
we
I
can.
like that. This keeps okay. I just hope the thing doesn't kick me out again. That was kind of annoying.
No, I meant, are we done with this problem?
Sure, you got 0.
No, that's just the 0 at the point where it meets.
No, that's the length of the curve.
Oh,
That integral is the length of the curve.
So the curve's length is 0.
Yeah.
That means like kind of it has no length. So
But how can that be? I drew it. There it is.
yeah, that doesn't make any sense.
Okay, so something went wrong. Or maybe not.
Is it? You don't put that 0 back into the original equation, right? It's not like 1 plus cosine theta, which is now cosine 0, which makes it 1, so that would make it 2. That's not what happens.
No, look, so here's where this is the formula for the length of the curve. Right here, okay?
Okay.
So here's the R. So I'm plugging it all in. I end up with this integral. That's fine. I get this. I do my clever step. This is the booger right here. What happened here is I was said that the cosine squared of theta over 2 square rooted was equal to just the cosine of theta over 2. Now, remember that the theta is running from 0 to 2 pi. So what is theta over 2 doing?
Doing that in like half the time or double the time it takes.
It goes, as theta runs from 0 to
Pi.
2 pi, half of theta runs from 0
To pi.
to pi. Okay, now, here is the graph of the cosine function up to where pi is. Okay, here's pi over 2, and here's pi. The cosine function goes down like this, and he goes under there. Okay, so on the interval, pi over 2 to pi, cosine of theta on cosine of theta is negative. Okay. You see it down underneath here? It's negative. And so when we say the square root of a negative number squared, we don't report it as -4. We do this, which would require us to do this. So, point that I'm making here is that as we did this integral right here, when theta got to pi, theta over 2 starts going as pi over 2, and the cosine of those pi over 2s until it gets to pi are all negatives. So basically what happened was this. We added up all of this area, and then this area was all negative. I mean, not area, length, because of that problem. Okay, so let's see if we can fix this. Okay, by symmetry, the length is going to be the integral. It's going to be twice the integral from 0 to pi of the square root of r squared plus r dot squared d theta. Okay, so if we go back to where we ended up, let's go back to this guy right here. Okay, I'll rewrite it down. It was, what did I have out there? I had a square root of 2, 0 to 2 pi, and then it was the square root of cosine squared of theta over 2 d theta. Is that right? No, there was another 2 in there. Okay. So what we're going to do now is we'll say it's going to be twice this integral when I go just from 0 to pi of the square root of 2 cosine squared theta over 2. So now as theta goes from 0 to pi, theta over 2 goes from 0 to pi over 2. From 0 to pi over 2, cosine is positive. So now we don't have this problem. So now this is going to be a 4 out there because of that other guy. And then 0 to pi. Oh shit, another message from President Suarez. I went on campus today. But I told Tara, so I'm okay. Cosine of theta over 2 d theta. And so now that's going to be 8 times the sine of theta over 2 d theta, and evaluated at 0 and pi. And so that's going to be 8 times 1. So the answer is 8. That seems kind of weird, doesn't it? Okay, now this would fit inside a circle of radius 2, right? And a circle of radius 2 has an area of 3.14 times 4, which would be 12. Okay, and this number 8, shockingly, is so exact, but that's what we get. Okay. All right, now here's where things could get problematic. All right, we got lucky in that the red kind of canceled and gave us a nice 0. Okay, but it's not really all that big of a stretch to think that we could have some closed polar curve, you know, doing something weird like whatever. I didn't mean to dent it there. But only in this part of the curve did we screw up. Okay. Now, the reason I was asking us to question the number we got, because it was 0. The answer to this one correctly is 8. All right. But if we would have gotten 6 the first time, I don't think we would have questioned anything. we would have thought, okay, that seems to be good. So anytime you're dealing with these square roots of things squared, make sure the guy underneath you have the handle on if it's positive or negative. Okay, so let's try this guy. R equals 5 to the theta. I don't know what the hell that's all about, but anyway, 0 less than or equal to theta less than or equal to pi. Find the length. Okay, so what happens here? Anybody want to figure out how this looks when you graph it? Maybe if you have a TI-85, and mine doesn't have batteries in it, but if we graphed R equals e to the theta, or 5 to the theta, when theta is 0, R is 1. So there's a 1 right there. Okay, so that's where this picture starts in the XY grid. Okay. And as theta increases, the e to the x function increases. So that means the R starts to increase. And so I think what's happening when it ends at pi, the e to the pi number, whatever that number is, what's e to the pi? Let's see, 2.718. Can't do it like that. I have to get into the other one. 2.718 raised to the 3.14. It's like a negative, it's like negative 23.09 something. Okay, so we want to figure out the length. Okay, so let's see here. Do we want to stick with 5 to the theta? How about we write it as 5 to the theta as e to the natural log of 5 to the theta, which we will then settle on equaling e to the natural log of 5 times theta. Okay, so just think of that's e to the 2x, that the number sucks. Okay, so the length then is going to be the integral from 0 to pi, the square root of the r squared. So if I square that thing, I multiply the exponents, right? So that's going to be, well, here, let me write the whole thing out. E to the natural log of 5 theta squared. And then the derivative here is going to be natural log of 5 e to the natural log of 5 theta squared d theta. Give me a second to catch up there. I gotta use restroom real quick. Be back in 20 seconds.
Very lucky number.
So, what do you guys feel about this whole section?
I want to throw up a little bit.
Yeah, dude, this blows. Like, honestly, like, it's just every problem is so ridiculously long. Like, and I get that that's calculus, and I get that all the problems are supposed to take up a whole page, and I get that it's supposed to take 40
Dude,
minutes to do one.
there were nights when I was doing homework and I was like, I maybe went through like 5 pages just to solve one problem.
It's just so ridiculous, dude. Like,
And
and this is,
each page was like an hour.
I just like, I've definitely, and I mean, for those of you who don't have a bachelor's degree, you're definitely in a better place than I am because there's tons of funding for you. But like for people like myself, like with everything going on, it's like, I'm wondering if I should even keep taking this stuff, dude. Like once I get my master's, I'll be 35. Are there going to even be jobs left in California? I don't know if you guys have read the recent news, but they told everybody recently if you have a job that closed, you should just quit and get a lower paying job because you're not getting your job back. So that was the new announcement from the government today. So it was great. I loved it. Love that they're like, hey, take a 75% pay cut and take some crappy job because we're closing your business permanently.
We're pretty much convinced that our kids will be living with us forever.
Oh, dude. I mean, I sadly with my 76-year-old parents, my dad turned 76 yesterday. There's a possibility we'll have to move back with them, man. If this stays the way it is, like people can't switch job careers in a matter of days nowadays to like good careers. So. But,
okay. So after we square this out, let's just finish this problem. 2 natural logs of 5 theta plus the natural log of 5 squared e to the 2 natural log of 5 theta d theta. Okay, so what we're doing here is we're kind of managing a mess. So if I write it as, if I factor that thing out, the e to the 2 natural log of 5 theta, it's going to be times 1 plus the natural log of 5 squared. Okay, so that's a number. Okay. Okay, so here comes now the big step. I'm going to take the number out. Okay, so the number outside is the square root of 1 plus the natural log of 5 squared integral 0 to pi e to the 2 log 5 theta to the 1/2 power d theta. Okay, so obviously what I want to do here is cancel those things. Now, we don't have to worry about things being negative because e to the anything is always positive. So it's going to give me this crappy number in front. Then times the integral from 0 to pi e to the natural log of 5 theta d theta. So it's going to be crummy number times 1 over the natural log of 5 times e to the natural log of 5 theta, evaluated at 0 and at pi. And if we want, we can turn e to the natural log of 5 theta back into e to the natural log of 5 to the theta, which is just going to be 5 to the theta. Might be a little bit easier to work out. 1 plus the log of 5 squared divided by the log of 5 times 5 to the theta, 0 and pi. And so it's going to be this number doesn't look good. 1 plus the log of 5 squared all over the log of 5 times 5 to the pi minus 1. Okay. Now, the kind of question that people would ask, well, you know, why does this have to look so weird or whatever? If you just randomly write things down, they don't integrate. So you'll see when you start getting into higher level physics, especially if you're a physics major, like a junior or something, when you're taking mechanics, you're just hoping and praying that the thing has an antiderivative. Because the last thing you want to do is go have to approximate by using Taylor series. All right, so let's look in the chat here. See if anybody has homework. As far as questions go in this section, you just do a bunch of them, you know. Try the harder one.
Any in specific? Any in specific?
Anything specific?
Yeah, like any of them, like.
I could go in the chat, but so the problem here is we all have different. See, some of the books, they have this section, the 10.4 is broken up into a couple sections or something like that, or but anyways.
Yeah, I think I have the same version that you have downloaded on my phone. And what I like to do is just usually when you say a number, I usually do like that one little section with those numbers around them. Either way, I might hit the one that you would say.
So you can go up to 48.
Okay.
And they come in little packets, you know, like just little packets, find the area, inside, outside, and all that stuff. Okay.
Okay.
I wanted to put a curvature problem on the little assignment thing, but I didn't. So that's that. You want me to read you? Let's see what President Suarez said.
Oh.
Let's see what this is. Office of the.
I'm sure it's great news.
It can't be
Just waiting.
all that bad.
Oh,
Oh,
she's
man.
just saying. So the
I don't know if
administration.
you've turned on the news, Eduardo. It can't all be that bad.
So far.
It's the immigration status thing.
What did they end up figuring out?
They backed out of it. They somehow blocked it, or the White House removed its support, or I don't know.
Good. The schools all would have been bankrupt, man. But,
Yeah.
I mean,
You
whatever.
still got all these travel issues, though.
Yeah, I mean, they can't travel, and it's like that part is bad, but like just kicking out a bunch of people and sending them back to their home countries, they're not going to want to take online classes from, in my opinion, from like a country where it's like, oh, I can't, not legally allowed to be there. Also, they like, if things ever reopen again, they totally bring tons of stuff back to the economy. Like UCI, that whole entire shopping center was created just for students. And I forgot what percentage of their student body, but they have a ton of international students at UCI. So, hey man, probably smart that they backed off. But yeah, well,
I don't know what the hell is. Gray Davis has got to realize that he can't. That you can't just kill the economy.
Oh, you mean Gavin Newsom? I was wondering. I was like, Gray Davis. He's been a while. It was a while ago, man. I was like,
he's stuck in my
Yeah,
head.
no, I remember. I was able to vote.
Real loser.
Yeah. I miss Schwarzenegger, dude. I dug that guy. I know nobody else seemed to like him, but I always thought it was fun. That hard governor.
Funny guy. Again, ended up at the end of his term, about like a year later, he bought a tank.
Oh, really? Oh man. And did he also lift a tree branch over his shoulder? Because that would be.
I don't remember hearing about that one, but I remember hearing him buying a tank and having it on his ranch and just destroying random things with like a random person that he selected from like a comment section. So.
Yeah, that's a lucky person, man. That's the assignment until tomorrow. Yeah, till 5 June.
I put the due date 5 o'clock tomorrow. A couple of these questions are gonna give you a little.
I think number 10 sounds like it's impossible, so we'll find out how to do it.
Have you guys seen the Greyhound movie yet?
No, is it okay?
Oh man, it's badass.
The Tom Hanks one? So I'd say
Yeah,
Tom
it's awesome.
Arnold. That would have been better. What
I've
happened?
watched it almost twice.
Really? Okay, I'll check it
Last
out.
night I couldn't broadcast from my stuff. It depends on your queue on the Wi-Fi, you know, I guess.
Okay. Yeah, I
So-
have Apple whatever because it came with my phone, but I don't have it. It's not an app on like my TV or any of like my consoles, so I can only watch it on my phone or my iPad. So it's kind of like a pain. You have to have
you
an
have
Apple.
you don't have a TV that you can cast to?
Oh, I have a TV, but not that receives like casting. The last time I bought a TV, man, it was like 1080p, but this is like 5 years ago, and I'm like a pretty frugal dude, so I paid like $500 for like a 52-inch 1080p 4 HDMI TV at Costco, and nowadays you could buy a 4K 60-inch, all that stuff for the same price. It's TV value is like silly, so it holds no value. So I never like am encouraged to buy expensive TVs. It's like it's useless. So you're like, honestly, like I don't see. Do you have are you guys 4K, big into 4K or anything? I don't see a lot of value in it.
For the regular TV, like I have a regular size TV in our bed, like I guess like a smart. I have like a room where I just have like this. I really sanded the whole wall and just put a projector in, just because I was like, oh whatever, why not have like an entertainment place, right? They're cheap. I mean, the screen is what kills you. It's not really the projector itself.
Yeah, I was just seeing somebody got a Samsung QLED 60-inch 4K. That's a really nice one. Oh wow,
Yeah, that's a nice one.
that's a pretty. You paid pretty cheap, $650 for the 50-inch. But yeah, I don't know, man. So does Apple TV have an app on modern TVs, or do you guys have an Apple TV app? Like
Yeah, it's
Bobby?
most smart TVs come with like Amazon Prime, Hulu.
Yeah, mine comes with Hulu
yeah.
and Amazon Prime and Netflix, but Apple TV was like, I mean, you don't really need it. I mean, they only just made the service this year, and I mean, since it's free, I can't really complain. But if it would cost me anything, I could complain because it's a pretty.
Oh, I've got so many monthly charges now. I don't
Oh
even
man, you
anymore.
gotta be careful. I start those and then I cancel them after like a month. Like I have right now HBO.
Well,
Max.
I forget. So like, for example, back when I was playing golf a lot, I joined the club at the golf course over by UCI, Rancho San Joaquin. And
Yeah.
for $40 a month, I always got twilight time rates for playing and stuff.
Oh, okay.
Well, then I stopped playing as much, and I don't know how to cancel the thing. So what I did is I just canceled the credit card that it was going to. And so then, yeah.
Man, I don't know. Those services, that's how they get people. I had a buddy who was paying for like a year for one of those things. And that's why the gym ones are miserable. That's why as soon as they open, I need to just cancel, even though it's like $10 a month. It's like, because this stupid thing where now they're closed and now they're open, now they're closed, now they're open. Just be
Wait,
better to buy
what do you have for $10 a month?
Planet Fitness because it's
Oh.
cheap. I just go to
I have a
Walmart.
friend that long time 24-hour fitness would
Yeah.
do this.
It's
They
cheap.
grandfathered him in
$5.
to any club he wants, and it was like $5 a month.
It's crazy, man. Yeah, no,
It was
my
like
sister said that
25
too.
years ago or something like that.
They
Or-
did that a few times, but the last time I had 24, it was 35 a month, and that was just for the one on 17th, not the nice one. So when I tried canceling because they made that miserable, I told them I was going to be out of the country, which I was for a while, and then they just froze it, and then finally they just never reinstated it, which I lucked out
Mhm.
because they really did not want to let me cancel that. That took me 30 minutes to get them to freeze it. So
Yeah.
You know, Planet Fitness or what I like that. No, it was a 24-hour fitness. I hate their free.
the
Want to
what?
cancel before your month is out? They charge you extra, and then they want to convince you to upgrade so you don't have to cancel.
Oh yeah, I mean all this stuff, man, is just it's ridiculous. I really feel for those companies though, because they were like as crazy as it sounds, they were all on like hair thin margins before
Mhm.
this. So like it sounds insane because they charge a lot of people monthly and a lot of people don't go. You would imagine they were just raking in the cash. But from what I've gathered, a lot of them were like barely making it, and now they're been closed for what 4.5 of the past 5 months, and they're probably looking at another month or two before we. I mean, Gold's gym already closed, but Gold's was kind of like permanently closed. But Gold's was kind of like a smaller niche gym, and we have 1 million of those anyways. So yeah, I guess it's a good time. Like if you have a garage, just buy your own equipment. It's crazy expensive, but just do it, and then you never have to worry about the government, till they take your house, coming and like saying, hey, you don't have equipment anymore.
I spent a small fortune on the gym in my backyard. Somehow I got maybe if I bring it up on my phone. I have
just free weights can cost easily $600 to $700. I haven't purchased them myself. I've been meaning to, but like I've heard like a good 5 sets of free weights can cost like that. And that's insane to me. But
have you tried the multi-weight? The multi-weight's like 100 and something bucks. It's just literally like that one where you twist your wrist and it locks the different weight on.
No, I haven't seen this. I can kind of see the picture on your phone. Oh, it's nice. So you got a bench. What else do you have?
Let me play it again.
Okay, now I can see it. Oh, nice. Wow. That's in your backyard. Do you have a garage in your backyard or something?
Yeah, the garage is in the back. It's a 0 lot line.
Oh, okay. Oh, you don't have a
Weird.
lot line with your neighbor. Oh, that's weird.
Well, we put in a fence just recently to do it, but we have an easement onto his property.
Oh.
So I can do anything except the leg press.
The only bummer for you is you're outside. So if it gets crazy hot, I mean, I know that you're probably fine with it, but for me, like the reason why I had the gym pass was, hey, it's crazy cold, crazy hot. I can't run in this weather because.
Yeah, well, this has to come in the garage, but
Yeah.
It gets used like today. The gym, it got used 4 times.
Yeah, I assume your kids.
I used it, and then I went over to my friends to finish the workout, and then my older boy and his friends used it, and then my youngest son, his buddy came over, they used it, and then at 5 o'clock, my wife and sister-in-law and a neighbor come over, and I have a little circuit for them.
Nice.
It gets used more than the jacuzzi.
It's worth investing in. I know it doesn't sound like you want to because you like going to the gym, but if you were willing to cancel your membership, it would probably make sense. It would probably, because you're at the one at Triangle Square. I saw you through the window when I was driving by one day.
Yeah, I even have a buddy membership. I think my membership is like $50 a month.
Yeah. So it's $50 a month. So you're looking at $600 a year, and then you said you had Planet Fitness as well. So you're looking at like $800 a year roughly. It's for both of those memberships.
So I have a buddy pass. The buddy pass, I can bring anyone in I want.
That's pretty cool. I mean, do they let you use that though now with everything going on, or no?
Yeah, I've done it. I brought Tyler in, my son. All you have to do is wear a face mask when you go in there.
The whole time, or just when you're?
No, just when you're walking in.
Oh, okay.
Planet Fitness, they make you wear it the whole time now.
Oh, okay. Well, they're closed, right? Everything closed, or?
Yeah, somebody just told me one of the local Lowe's is going to convert half of its space to a Planet Fitness. That was my friend or my wife telling me that.
That would be the dumbest idea ever right now. I mean, normally I would be all in support of that. Those stores are all way too big. Their overhead's ridiculous. But right now, I mean, you don't want to do anything with services. Anything that's indoor and service-based, stay out of it. Like I wouldn't invest in a restaurant or in anything for, I don't know, at least next year, maybe 2 years from now, 3 years. So
I got a question for Professor. Do you think UV lights, if for whatever, they have UV sanitation lights, like a flash to disinfect whole rooms? Do you think that would be like a smart idea to have at the gym, that like for people that want a gym, maybe after every 2 hours have it just go off?
Used to be that in hospitals they had lots of copper and copper handles and stuff. It's like some property in it where the viruses and germs they don't survive. Something about copper.
Mm.
Well, that's actually kind of the more interesting thing is like the swim schools, which those pools are just filled to the brim with chlorine, like nothing can survive. most of those have closed down. So that was one of the things I thought was pretty interesting because, like, I mean, I have two sisters who work at two different swim schools, and one of them closed, the other didn't, and it was like, man, I've been in those pools. They will like burn the flesh off your skin after a few hours because there's just so much chlorine in there. But yeah, they still closed it. Like I said, I mean, I mentioned this a few weeks ago. I think the way that things are being closed down is nonsensical, but you know, whatever. I'm not in charge of anything. So like I told my sister, I'm welcome to have an opinion for at least right now. And then maybe I won't be able to have that in the future.
Was it Taiwan was the only one that literally just like got ahead of everyone and literally?
Yeah.
Okay, here's what I'm watching right now in the news.
Uh-huh.
The news is reporting, are we getting ready for panic buying number 2?
Well, by reporting that, they probably will.
Yeah.
This is what, and you know, this is what makes guys like Trump so furious, because they're saying this just, you know, now there's going to be panic buying.
Yeah. Well, you know what though? I'm hoping it's one of those like false reports, like
They find one person to say, yeah, I'm going to go buy, or they say, hey, are you worried that there's going to be another run on toilet paper? And the person they just interviewed, like, puts the stuff in their car, locks it up again, and goes back in and buys more toilet paper. Thanks to these idiots.
Hopefully they will do the thing that they should have done the first time, which is limit how much toilet paper people could buy. That was a big problem immediately the first time. They're like, buy whatever you want. The other thing is, I'm hoping it's kind of like, I don't know if you guys remember during this, they've been closing down a lot of like meat factories, which honestly at some point will affect us. But there were stories a month in that by Friday we were going to be on a meat shortage. And I've gone to the grocery store. This was like April. I've gone to grocery stores probably 50 times since April, and there has not been any shortages that I've noticed. But so it's one of those things where, like, yeah, there's going to be meat shortages in the future. You can't close down every single industry and expect for there to somehow be 100% product rate. Like that, it just doesn't work. You know, you close down 40% of the businesses, you can't expect them, the other 60, to make up that deficit. So yeah, I mean, there's going to be meat shortages. There's going to be inflation. That's just guaranteed. But I don't think it's going to be right now.